Welcome to the deep dive, exploring the innovation of Thunderbolt Fusion technology proposed by DeepMatrixLab. A fundamentally different approach from conventional fusion. What exactly is its mechanism? What does it mean for you? Let's dig deeper. It tackles a problem conventional fusion research has wrestled with for decades. How it can find that super hot plasma, like the core of the sun. It's a massive barrier. The point is, they're trying to overcome it with a completely different approach. Instead of heating the plasma, they strike it with electricity, like lightning strikes. And the fuel isn't gaseous plasma. They use liquids or solids. That was the first thing that really surprised me. How does this mechanism work? What they focused on was the properties of insulators. Yes, insulators. Materials that normally don't conduct electricity, right? They apply an extremely high voltage to them at lightning strike levels for an instant. Yes, lightning strike levels. This causes a phenomenon called dielectric breakdown, where an incredibly powerful current, just whoosh, flows through material. Just powerful current. The idea is to take this electrical energy and use it directly to heat the atomic nuclei into fuel. That's the theory behind triggering a nuclear fusion reaction. So it's done directly using electrical force. Moreover, the report also mentioned a density about 2.2 billion times that plasma, a staggering figure. It says they combine this high density state with an electrical shock and mechanical compression. Is this the key of the tech? Exactly that combination seems to be the crucial point. Solids and liquids already have high density. Compressing them further and then directly injecting electrical energy into them. This overcomes the repulsive force between atomic nuclei, right? The Coulomb barrier, the Coulomb repulsion. To overcome this more efficiently, rather than forcibly breaking the barrier, they aim to increase the probability of atomic nuclei tunneling through the barrier. The quantum tunneling effect. Tunneling through. That seems to be the objective. Making it easier to slip through the barrier means that unlike conventional methods, that would need to heat the entire system to extremely high temperatures. Exactly. So there's a possibility that nuclear fusion could occur more easily? That's the claim. The overall temperature could be relatively low, but the energy is concentrated where it's needed. That's the idea, right? If this can truly be realized, the energy efficiency required for fusion could increase dramatically, and the device itself could become much more compact. The report even mentions applications beyond power plants, like cars and jet engines. An energy source the size of an engine? If that's true, it could fundamentally change the very nature of energy. Well, the downscaling. If it's proven, that is, but the potential is definitely there. Fusion might become usable not just for huge, centralized power plants, but as smaller, decentralized power sources. The implications for energy self-sufficiency and infrastructure are immense. Plus, they're aiming for cleaner reactions, right? Like the DT reaction we often hear about, deuterium and tritium reactions, which produce radioactive waste. That's the proton-boron reaction P11B reaction, which is called an aneutron reaction. Aneutron. It's considered cleaner fusion because it produces almost no neutrons. Inducing this thermally is extremely difficult, but this electrical approach might just open that door. Of course, this is a very big if, but the significance is huge. When I think about what this technology means for you, it's about CO2-free, low-cost, highly safe, location-independent energy supply. This is the future vision DeepMatrixLab is painting. If it truly becomes reality, it would be a real game changer.